Hi, welcome to LangGraph Basics. So far, we know how to build individually one graph, how to execute it, test it. We have built many graphs so far. Now, in this example, what am I going to do is, I'm going to create two different graphs. And the second graph is going to be part of the first graph. The first graph, I'm calling it as an orchestrator because he is the one who is going to make invocation of the subgraph internally. Let's understand the activity by referring the diagrams. So there are two graphs available here, the first graph and second graph. First graph is orchestrator graph, second one is the git graph. The git graph is about, it is having only one node. That node is going to read pull request from the git. It is going to read list of files that are modified in the git. The first graph is the one who gets the input of PR details, pull request details. Ideally, the first graph should act like a orchestrator. So the moment it reaches to the git node, what is that it has to do is, it has to connect with the ask for the second graph to get the PR details. This is exactly I'm going to make it. So you see both the graphs are connected. So the moment git node is started executing, it invokes the subgraph to get the pull request. Input to the subgraph is the PR details. After performing all the operations, second graph is going to return the PR related files that are modified. So that means orchestrator is going to pass some data to subgraph. Subgraph, after doing some operations, it is going to return some values. This is exactly I'm going to do with an experiment with a simple code that I have. Let's see how does it. Let's build the orchestrator graph individually. So if there are two nodes available, git node and our output node, which I built it here, no fancy. All the nodes are created, two nodes, connected all of them. Building orchestrator graph is done. Now I'm invoking the orchestrator graph with the PR details. And then which is going to return the final state of the PR. Okay, two things that you need to really focus on. The state of the orchestrator. State has two different values. One is the PR details, which is given as an input while invocation of the orchestrator graph. The second one is the git agent data, meaning when it is invoking the git graph, which is a subgraph, this value gets filled with the return value of the subgraph. So orchestrator is the one who is going to maintain the subgraph data as part of its own state. That's exactly it is going to do. Let's execute the code. Let's invoke the orchestrator. Invocation. Now you can see orchestrator is printed, it is invoked. Input is git URL. Output is whatever the input is given, that value the filled in the state. And the second value in the state is git agent data, which is of course none. At the end of the git orchestrator, the PR details is still be the same, and the final value is also same because it is never invoked git agent internally. Let's build the second graph, the git graph. So it is having only one node, we built it. And then I'm invoking the graph from here with a pull request. Remember, the git graph still be an individual graph. That means it can be invoked individually. I'm invoking it. The main important thing that we need to really focus is the state of the graph, git graph. So PR details, to which PR it is going to read. This is an input. And then finally, this git graph is going to fill this value, PR files. That means what? With respect to the PR, what are all the files that are changed? Those file list it is going to maintain in its own state. Okay. So now the first node, when it starts executing, it is printing git agent is invoked. Then whatever the pull request details got an input printing. And then PR files that it is going to populate is a static values. Two different file names it is maintaining. It's a list of files that I'm maintaining as part of this state. Let's execute this code and then understand the output. Let's run the git agent. You see, git agent started invoked. Input is PR details, and the values that it is going to return is two strings. which are file names. And then at the end, the git agent state is with the input data and also the return value that it is going to return. Done. So git agent is also started running. Now we know both the graphs can run individually. So we have seen the results, output, everything is fine. The core important point for this demo is how do you make the connection between them. That means how to make the git graph is a subgraph of the orchestrator graph. Meaning the git node in the orchestrator is going to invoke the subgraph by providing the PR details to git graph. The git graph, it is going to do that operations, reading all the PR related files, and those PR related files it is going to return to orchestrator. So orchestrator is going to maintain that PR files into its own state. This is the whole purpose. Let's implement it. Let's implement the code. So I have an orchestrator code which we already executed independently, and then we have git agent code which is also independently executed. Now I'm going to make changes only into 3 locations. First changes, do you see this? We built a graph, okay, for the git agent side. So this is the graph that is built already. This graph I'm going to import it in the orchestrator side. Okay, I have imported as a git subgraph. This is the first change. The second change that I'm going to do in the orchestrator is this. So I'm going to invoke the graph, whichever the graph that I have imported. I'm invoking this subgraph. I'm passing the data. What is the data? Data is nothing but that PR details that we wanted to pass as a dictionary. PR details. Now, after invocation, subgraph is going to return a value. That return value consists both values, PR details as well as the PR files. That is the return value. From that return value, I'm only extracting the PR files and then storing into orchestrator git state. That means this data. I'm maintaining it here. So this is the 2 changes in the orchestrator side. In the git agent side, I'm not going to make any changes. Rather, I'm going to comment out invocation of graph when it is run individually. That I'm just commenting out. We don't need to invoke it. This is the change. Let's execute the code. Let's see what is the output. So orchestrator invoked, and it received the pull request details. Immediately it is invoking git agent, receive the PR details, and then these are the values that it is going to return. Then control is reached to the orchestrator, and see the git. This is the return values that he has received, and finally these values are stored into the orchestrator state. So I could achieve passing some values from orchestrator to the subgraph. Subgraph, after processing the data, it is going to return a value. That return value is reached to the orchestrator. He is maintaining the values into the state. That's all. Thank you so much.